Hi everyone, good morning. I am Sanat from IIT Bombay Electrical Engineering, and currently I am in college in my first year. So today we will solve vector algebra NCERT chapter 10. So what is a vector? So a vector is a quantity, physical quantity, which has magnitude and direction. Okay. So any quantity which has magnitude and direction is called vector. So let us solve exercise 10.1 and get to know more about vectors. Okay. So the first question, represent graphically a displacement of 40 kilometer 30-degree east of north. Okay. So let us start. Let me make the first direction coordinates. Like this is north, this is south, this is east, and this is west. So what we know about our vector is displacement is a vector. Okay. And magnitude of displacement is given to us 40 kilometer. It is 40. And direction is 30-degree east of north. It means we have to move 30 degrees in direction east from north. So this is our north. So let us move 30-degree east of north. Okay, so 30-degree east of north implies this angle to be 30-degree. So we started at north and moved towards east. So this is north, this is east. So we move towards east in 30-degree. Okay, so this is 30-degree east of north, and its magnitude, vector's magnitude is 40 kilometers. Okay, so this is our graphical representation of vector given in question number 1. Okay, so let us move to question number 2. Classify the following measures as scalars and vector. So what is a scalar? Scalar is a quantity which have magnitude but no direction, and vectors are quantity which have both magnitude and direction. Okay, so let us analyze the following questions. Like question number 1, 10 kg. So 10 kg is mass, and mass has no direction. Okay, as we all know, mass has no direction. So this is a scalar. 2 meter north of west. As we can see, the direction is given here, north of northwest. Okay, so this must be a vector, 2 meters northwest. Similarly, angle. Angle has magnitude but no direction. Okay, like you cannot classify direction for angles. So angle is a scalar quantity. 40 watt. So what is watt? Watt is the unit of power. Okay, and power have no direction. So power is a scalar quantity. 10 to power minus 19 coulomb. Okay, so this is coulomb is the unit of charge, and again charge is no direction as we know. So this is also a scalar quantity. And last 20 meter per second square. So meter per second square, as we all know, this is the unit for acceleration, and acceleration have directions. Okay, so sixth bit, that is acceleration, is a vector quantity. Similarly, question number 3 again, we have to classify the following vectors and scalars. Time period. Again, time period has unit second and no direction. So this is scalar. Distance. Okay, this is nice. Distance and displacement are two different things. Like distance does not have direction. So distance is scalar, but displacement have direction. So displacement is vector. Okay, so distance is scalar. Force. Force have direction as we all know. We apply force in northeast. So in directions we specify along with force. So force is a vector quantity. Velocity, again, force, velocity, acceleration, displacement, all are vector quantities. Work done. Work done is a scalar quantity. Okay, as its unit is joule, and we do not need to specify the direction for work done. Work done is joule. So let us move to question number 4. Identify the following vectors as co-initial, equal, collinear, but not equal. Okay, so what is a co-initial vector? Let me explain. So co-initial vectors are the vectors which have same starting point. Like this is a starting point. If I draw two vectors which are originating from same starting point, these two vectors are called to be co-initial vectors because they are starting from same point. What are equal vectors? Equal vectors are the vectors with equal magnitude as well as direction. These are equal vectors. And collinears are vectors which have same line of support. They may be anti-parallel, parallel, but their line of support should be same. Okay. So let us now analyze the following. Co-initial vector, same starting point. As we can see in this figure, like vectors A and D, they have same starting point, that is the top left edge of the square. Okay, so vectors A and D have same initial point, so they are co-initial vector, equal vectors like equal magnitude and direction. So vector B and D, you can observe vector B and D have vector B and D same direction and same magnitude. Okay, so vector B and D are collinear but not equal. Collinear but not equal, it means antiparallel vectors which are A and C. Vector A and C have parallel support, but they are in opposite direction, so they are not equal. The direction is not same, but magnitude is same. So they are collinear but not equal. Okay. So let us move to question number 5. Vector A and minus A are collinear. As I explained here, like this vectors, antiparallel vectors are called collinear, also called collinear, because they have same support. Their directions are different, but they are collinear. Okay. So A and minus are collinear. This statement is true. Two collinear vectors are always equal in magnitude. No, this is false. Vector A, 2A, 3A, 4A, 5A, all are collinear vectors, but they have magnitude. They do not have equal magnitudes. Okay. So this is a false statement. Two vectors having same magnitude are collinear. So this is again false. Like I can draw magnitude in same vectors with same magnitude in any direction. So this is also false. Like I can draw between angle between them to be 30 degrees, 60 degrees, 70 degrees, but they do not necessarily need to be collinear. Okay. Two collinear vector having the same magnitude are equal. So this is also false, because equal vectors are vectors having both magnitude and same direction. Collinear vectors may have opposite direction, like example A and minus A. Okay, so they are not equal. A and minus A are not equal, but they are collinear and have same magnitude. So this is also false. So our answers are true, false, false, false. Okay, see, as we can see, vectors are, this was kind of theory exercise 10.1. So let us move to exercise 10.2 and know more about vectors. Okay, let us now calculate about vectors. So this is our exercise 10.2. To start, compute the magnitude of the vectors. Okay, so what is the magnitude? Magnitude of, suppose our vector is given by A equals plus yj plus z cap. So magnitude of A is given by under root x square plus y square plus z square. Okay, so if you know this question is very easy. Okay, so magnitude of any vector is given by under root square of its component in each direction. Okay, so here we are given three vectors A, B, and C. We have to compute the magnitude for vector A, I cap plus j cap plus k cap. We know mod A equals under root 1 square plus 1 square plus 1 square, that is 1 plus 1 plus 1 equals root 3. Okay, for second part B is 2 minus 7 minus 3. So mod B is 2 minus 7 minus 3, which is implies 2 square is 4, minus 7 square is 49, 3 square is 9. So 9 plus 4, 13 plus 49 is 62. This is root 62. And third part, that is mod C. So question number 3 was 1 by root 3 plus 1 by root 3 minus 1 by root 3. So if we square it, this is 1 by 3 plus 1 by 3 plus 1 by 3. That is 3 times 1 by 3. So its magnitude is 1. Okay, so any vector with magnitude 1 is known as unit vector. Okay, you can remember this term unit vector. Okay, so first question is done. Second question, write two vectors having same magnitude. So two different vectors. Okay, so they must not be equal, but they have same magnitude. So yes, we can change the direction easily. We can change the direction of vectors. Okay, suppose we have a vector. I will take simple coefficients 1 over I cap plus j cap plus k cap. Its magnitude is root 3 as we calculated now. And I will take another vector which I need to make different. So I will not change the coefficient, but I will change the direction. I cap minus j cap minus k cap. So if you calculate its magnitude, it will again come out to the root 3. If you square x square plus y square plus x square, in both magnitude will be root 3. So they are two different vectors having same magnitude. Okay. So now question number 3 is write two different vectors having same direction. So two different vectors having same direction means we have to make the magnitude different but direction same. So you can take any vector that is A. This all vector have same direction that is A, but their magnitude difference. Okay. So A is I cap plus j cap plus k cap, and 2A is 2I cap plus 2 times I cap plus j cap plus k cap. So they have same direction. It is I plus j plus ky root 3 unit direction, but they have different magnitudes. Okay. So this is also possible. You can write two vectors having same direction, different magnitude. So what is given to find the value of x and y so the vectors are equal. Okay. For equal vectors, we know this is like very simple question. The coefficient of 2 plus 2y plus 3j must be equals to xi plus yj. So x must be equal to 2 and y must be equal to 3 to make it equal. Okay, so vector completely equal. So question number 5, find the scalar and vector components of the vector with initial point 2, 1 and terminal point. Okay, so let us conclude this. Means points are 2, 1 minus 5. So let us take starting point to be A. Position vector of A is 2, 1 that is 2i plus c. Position vector of B, let us call it OA vector from origin from OB vector. B was minus 5 from S. So vector AB is position vector of B, that is endpoint position vector of A. But this is very important, you must know this. Or graphically also. A, this is B, this is OA, this is OB. So OA minus OB is B minus vector AB. This is vector AB. Vector AB is OB minus AB. OB minus OA. Okay, so this is very important. So now apply this. OB minus OA will give you minus 7 plus 6. So minus 7, minus 5, minus 3, plus 6. Okay. So this is vector AB. So scalar component of AB are the coefficient of I and j that are minus 7 and 6, and vector component are minus 7 I cap plus 6 I cap. Okay, so scalar component is minus 7 and 6 without direction, and vector components are minus 7 I cap and 6 j cap. Okay, these are called scalar and vector components of a vector. Okay, so let us move on to next question. Question number 6. Find the sum of vectors A, B, and C. So this is very easy. You don't need to write for this. Vector A plus B plus C, we need to add coefficient wise. So I cap minus 2 I cap plus I cap. This will give me 0 I cap. Okay. And B is minus 2j plus 4 minus 6. So minus 2 plus 4 is 2. 2 minus 6 is minus 4. Plus 0 I cap. Plus we add minus 2 plus 4 minus 6. We get minus 4. 0 I cap minus 4 j cap. And the last, if we add k cap plus 5 k cap minus 7 k cap, that is minus k cap. So this is our answer. We can also write it as minus 4j minus k. This is our sum of vectors. So you remember that adding vectors we add component wise along diagonal, like I gets added to I, j gets added to j, and k gets added to k. Okay. So now let us move to question number 7. Find the unit vector in direction of I plus c plus 2k. Okay, so what I said earlier, like unit vector represented by a cap. A cap is nothing but vector A divided by its magnitude. Okay, so this is called unit vector. You remember it, like this is called unit vector. is also very important in student. So here in the question, A is given by I plus J plus 2k, I plus J plus 2k. Okay, so mod A will be given by under root 1 plus 1 plus 4 plus root 6. So A cap will be I by root 6. So 1 by root 6 I will take out common. I cap plus J cap plus 2k. Okay, so this is our unit vector I cap plus J cap plus 2k, that is A itself by mod A, and mod A is nothing but root 6. So this is our unit vector of A. Okay, so the again question number 8, find the unit vector in direction PQ where P and Q are given. So first find the vector PQ. Like as I said, you know how to find the vector PQ. Vector PQ is vector OQ minus OP. Vector OQ minus OP in this question will give me um, 3, 3, 3 and 3. Okay, so this is nice. We got our OP minus OQ as 3 times I plus C plus 3. And unit vector is vector divided by magnitude, and its magnitude will be 3 root 3. As you can easily see, magnitude of PQ will be under root 9 plus 9 plus 9 under root 27, which is 3 root 3. Unit vector of PQ will be this vector PQ by magnitude, vector PQ by mod PQ, which is equal to 1 by root 3 I plus U plus K. So this is our unit vector. So this is our unit vector. So what we learned is unit vector is any vector which gives us the direction. What is direction? Vector by magnitude itself. Okay, so first find the vector, then find its unit vector. For question number 9, of the given vectors A and B, find unit vector in direction of A plus B. Again, this is quite simple. First find the vector A plus B, and we will find the unit vector in its direction. So vector A plus B is nothing but add the coefficients of A plus B. Adding coefficients of A plus B, it is 2 plus minus 1 will give me 1 I cap plus, we can say j component are equal minus j and plus j, it will give me 0 j, 1 I cap, 0 j cap plus third component is 2 and minus q, this will give me plus k cap. So what I got a plus b vector is I plus k. Okay, so its unit vector will be simple I plus k divided by root 2. That is magnitude, this will be a plus b, a plus b cap will be I plus k divided by root 2. This is a very simple question. First we need to find out the vector, then its unit vector. All are kind of same. Okay, now given is find the vector in the direction of vector this with this magnitude 8. Okay, so what we need to do is first find out its unit vector that will give me direction, then multiply it by 8. First find the unit vector that will give me the direction. So vector is 5i minus j plus 2. This is the vector. Its unit vector will be divided by its magnitude. Its magnitude is 25 plus 1, 26. Plus 430. So its magnitude is root 30. This is our unit vector. Our found the magnitude was 25. So this is a unit vector. Now multiply it by 8 to get our answer. 8 times 8 by root 30. 8 by root 30 times the vector itself. So this is a vector in the direction of the given vector with the magnitude 8. So first find the unit vector. Unit vector is of magnitude 1 and direction of the given vector. So now multiply 8 to the unit vector to get a vector which has same direction and magnitude 8. Okay. So now we move on to question number 11. And question number 11, what does question number 11 says? So that the vector 2i minus 3j plus 4k and minus 4j plus 6 are collinear. Okay, so what do we know about? So if this lambda is a real number, we can say A and B are collinear vectors. This was the definition of collinear vectors. Now, can you say by simply observing vectors A and B, can you find out the lambda? Like lambda, I can find out the lambda as minus half. Okay, so you can see if I multiply minus half to vector B, second vector, we will get the A vector. Okay, minus half times minus 4 will give me 2. Minus half times 6 will give me minus 3. And minus half times 8 will give me 4. So we can easily see like multiplying minus half to this vector, second vector, will give me first vector. So yes, this is our vector collinear with lambda is minus half. You can easily see. So let us move on to question number 12. Find the direction cosines of the vector. Okay, so direction cosines of the vector are the component of the unit vector. Okay, so if we have given vector A vector is, if we have given A cap is equal to, so its direction cosine are x, y and z given it is a unit vector. So let us convert our question to a unit vector. So we have given vector I plus 2 I cap plus 2j plus 3k. So let me change the color and find its magnitude and divide it by magnitude to get our A cap. Okay, its magnitude is under root 9 plus 4 plus 1, that is root 14, divided by root 14. Okay, so what will get our direction cosines are 1 by root 14, 2 by root 14 and 3 by root 14. Okay, so these are called direction cosines. What is a direction cosine? Direction cosines are the coefficient of I cap, j cap and k cap of a given unit vector. You must know this, A must be a unit vector. Okay, for a unit vector, coefficients of x, y and z are called direction. Okay, so let us move on to next question. This question number 13. Find the direction cosines of the vector joining the point A and B directed from A to B. Again, this is same. First, find out the vector AB. We know the vector AB. So here vector AB, I will directly write vector AB unit vector in direction of AB. You can calculate yourself and check if I wrote correct or not. So I will write AB cap. AB cap is minus 2 minus 4 plus 6. AB cap is minus 2i minus 4j. I will write it neatly. AB cap is minus 4i minus 4j plus 4k. And okay, so I made a mistake here. This is minus 2 and 16 plus 2 is negative. 16 plus 16. Okay, this is my AB cap. And write it neatly as minus 1 by 3 minus 2 by 3 j cap. So my direction cosines are minus 1 by 3. It is coefficient of unit vectors. Minus 1 by 3, minus 2 by 3 and 2 by 3. Okay, so finding direction cosines are very easy. First you need to find unit vector, then take the coefficients of unit vector to find direction cosines. What we have to do in question number 14 now is we have to show that the vector I, j and k are equally inclined. What do we mean by equally inclined? That the angle it makes with the every axis, so x, y, and z are equal. Okay, so we can easily, what we know about direction cosines are their cos of angles. Okay, so the previous slide where I wrote this, a cap is xi plus yj plus zk. Here x is cos alpha Y is cos beta, and Z is cos gamma, where alpha, beta, and gamma are respective angles of A cap with X, Y, and Z axis. Okay, so if we find unit vector and we find out its coefficient to be equal, we can say they are equally inclined. Okay, so what we have given vector is I plus J plus K. If we find its unit vector, let me call it a vector A. If we find out its unit vector, we will get I plus J plus K by root 3. Now we can see its unit vector coefficient are equal. That is cos of equals cos of beta equals 1 by root 3. So angle alpha equals beta equals gamma equals cos inverse 1 by root 3. So as we now have shown that the angle alpha and gamma are equal, you know that this vector is equally inclined with the three axes. Okay. So what we learned from this question is the coefficient here of the unit vector gives us the angle, that is cos alpha, cos beta, and cos gamma. So let us move on to question number 15. So question number 15 says find the position vector of a R which divides the line joining the points P and Q in the ratio 2 to 1 internally and externally. So this kind of questions are also very common. Let me call it as P and draw a line. Let me call this point as P. Let me call this point as Q. And first we have to find the point R such that it divides the point in ratio 2 to 1. So here will be our R. This is 2 ratio 1. Okay. So we know the formula that what we know, we can find the position vector directly. Okay. So what we know is P is given as, if this is ratio is to shown, the vector R can be found out by 1 times P, like P plus 2 by 3. How we got this? If we have formula that is n ratio n, if P is divided into n ratio n, then P and Q, then R will be n times P plus n times Q by n plus n. If you know this formula, you can directly apply this and find out that P plus 2Q by 3 will give you nothing but minus I plus 4J plus K by 3. Okay. Similarly, for external division, you must know that external division formula is R equals NP, NQ, NQ minus NP. So it will be 2P plus K, NP plus NQ, NP plus NQ. Okay. So 2P here also NQ minus NP by M minus N. Our M is 2. So it will give me 2Q minus P, which will give me nothing but minus 3I plus K. So these are simply formula based questions. If you know the formula, you can easily solve this. Okay, let me show you this formula. So yes, here it is the section formula. We call this formula section formula. You can see the derivation also here. NCERT. Case 1, that if P and Q are internally divided by ratio M and N, you can see the formula is MB plus MA by M plus N for the vector R. And similarly with the external division, you can see the section formula changes to B minus NA by M minus N. You can check out the derivation in the NCERT if you need to know how the section formula came out. Like this is very simple. You can see easily. So let us move on to question number 16. So what question number 16 says is find the position vector of the midpoint of the vector joining these two vectors. Okay, so midpoint is very easy. If we have given vector P and Q, So midpoint R will be given by simply P plus Q by 2. So find this in question number 16, P plus Q by 2. P plus Q is nothing but 6i plus 4j plus 2k by 2. This will give me 3i plus 2j plus k. Okay, so this is our answer, midpoint. Let us move on to question number 17. So what does question number 17 so that the point A, B and C, position vectors A, B and C given form the vertices of a right angle triangle. Okay, so A, B, C gives us right angle triangle. So what we need to do is, like, how can we show this is a right angle? We know that right angle triangle satisfies a property known as Pythagoras theorem. Okay, we can also check by angle, but Pythagoras will be better as we don't know which vectors are perpendicular here. So let us show it by Pythagoras only. So what we have given, let me randomly call this ABC. We don't know which angle is 90 degrees. So we have given position vector of A, position vector of B, position vector of C. So let us find AB vector, BC vector, and CA vector. Okay, so this will be side vector. From position vector, you can find AB vector. AB vector is position of P minus position of A. It will come out to be minus I plus 3j plus 5k. Second vector is BC vector. BC vector will become out to be minus I. BC vector will be minus I minus 2j minus 6k. And CA vector. So CA vector will be 2I minus j plus k. These are side vectors now, and let's find out the magnitudes. So our first magnitude, AB vector magnitude will be under root 25 plus 9 plus 1. It is root 35. Our second magnitude will be 1 plus 4 plus 2. That is under root 41. And our third magnitude will be 4 plus 1 plus 1. That is root 6. Now we know the Pythagoras. You can see that a square plus b square is c square. That is 25 square. The root 35 square is 25 plus 6 is giving us 41. Okay. So what we also can check out is the angle it is 90 degree is at A. Root 35 square plus root 6 square is equal to root 41 square. This is a 45 right angle triangle. Pythagoras theorem satisfies, that is a square plus b square is equal to c square, where c is the hypotenuse of the right angle triangle. Okay, so that is a and b. So you can see this is the right angle. You can prove it to the right angle triangle by checking the Pythagoras theorem. In question number 18, you can directly see this is a multiple which of the following is not. Okay, AB plus BC plus CA will move directly. AB plus BC plus CA is equal to 0. Okay, so AB plus BC plus CA is obviously 0. You can check it out easily from the given figure only. AB plus BC. So CA is minus AC. So A and B both are correct. Option number C, AB plus BC minus AC. So AB plus BC, AB plus BC plus C is 0. But AB plus BC minus AC will not be 0. So option C is incorrect. So we know if we move across a triangle in a given direction, that is AB plus BC plus CA, we get out to be 0. This is called triangle addition rule. So we can see that option C is incorrect. Okay. In question 19 also, so the question like if A and B are two collinear vector, so the following are incorrect. You can see if A and B are two collinear vectors. Okay, so I told if A and B are two collinear vector, B vector is lambda and this is correct. B is plus minus B. So okay, we can say B A is plus minus B, but not always. Okay, so not always, because this is a case of A. Not necessary that it will the lambda will be. But yes, it's also correct, kind of correct. So this is partially correct. The component of A and B are not proportional. Both A and B have same direction but different magnitudes. Okay, so option D is incorrect. Like A and B does not need to have same direction. They may have opposite direction if lambda is minus 1. So option D is incorrect, we know. Guess option D is incorrect. About option A, we know this correct. Option D is a particular case of option A, so this is also correct. The respective component of A and B are not proportional. Respective component of A and B are not. We can see like are they proportional? Respective components of A and B. Actually. So this is correct. Okay, so yes, the incorrect option is option B. So we have completed exercise number 10.2, and now what we left are exercise number 10.3 and 10.4, 10.3, 10.4 and miscellaneous exercise. So let us move on to exercise number 10.3. So this is exercise number 10.3. Let us try to solve some of the question of exercise 10.3 in this video. Okay. So find the angle between two vectors with magnitude of greater than having A dot B 6. Okay, so let us learn a new concept, like not new, but angle between straight angle between A and B is given as A dot B by mod A mod B. Okay, so in this question, we have given A dot B to be root 6, mod A to be 3, mod B to be 2. So this is root 3, this is 2. So cos theta is 1 by root 2, so theta is 45 degree as well. Theta is 45 degree or pi by 4. So this was the first question we must know this formula. Let me make it. Cos theta is A dot B, where theta is angle between A and B. So again, second question, kind of similar. To find the angle, so first find A dot B, then find mod A mod B, and you can see this in check. So we also know that A dot B is we have to multiply the I component. We have to multiply component first. So multiply x1 into x2. So let me call it x into x2. Okay. The I component of both the vectors, the y component of both the vectors, y into yb j cap, and z components, it is z into zb. Find A dot B. This question, if you find A dot B, it will come up to 10. Mod A is very simple. Mod A is given by root 14. So in this question, mod A is mod B equals root 14. So we can easily check A dot B. Cos theta is A dot B, that is 10 divided by root 14 into root 14, that is 14. That's 5 by 7. So we don't know its value, so we will report theta as cos inverse 5 by 7. So let us move on to question number 3. Find the projection vector of I minus j on the vector I plus j. Okay, what we know about projection vectors is projection vector of, find the projection vector, wait a second, find the projection of vector I minus j on vector I plus j, right? So, vector of I minus j on I plus j. Okay, so this is kind of tricky question. Like I minus j and I plus j. Observe closely, these two are perpendicular vectors. You can see A dot B is 0. So these two vectors are perpendicular vectors. And the projection of perpendicular vector is always 0. Okay, so its projection is 0. It could not project anything on its. This is I plus C, this is I minus C. These are perpendicular vectors. So projection of perpendicular vectors are 0. Okay. So this was a tricky question. You can easily check that projection. You can also apply the formula of projection to check. That is projection of A on vector B is A dot B. A dot B by maybe A on B. Projection of A on B is A dot B by mod B. Okay. You can also apply this formula and you can see that A dot B is 0, so projection is 0. Or you can directly see these two vectors are perpendicular. So question number 4, let's move on to question number 4. Find the projection of this one vector this. So this is kind of similar, A dot B by mod B. If we do A dot B, it is 7 minus 3 plus 56. A dot B is 7 minus 3 plus 56. This is 60. Mod B is under root 7 square is 49 plus 5 square is 60. 50 plus 64 is under root 114. So projection is A dot B by mod B, that is given as 60 by root 114. This is our answer. Okay. So what we can do is projection of A on B is A dot B by mod B. Simple. So that each of the three given vectors is a unit vector. So what we know about unit vector is its magnitude is 1. You can easily check out its magnitude. I don't need to solve for it. 36 plus 440 plus 949. Root 49 is 7 by 7 7. So yes, every vector you can see. And to find they are mutually perpendicular, we know that two perpendicular vectors. So you must know that if A dot B is 0, it implies A is perpendicular to B because cos 90 is 0. This is simple. You must know this property and you can check this in question number 5. Okay, so in this video, we will solve till question number 5. The rest of the questions I will take in the next video. So we will solve the complete vectors. Okay. So yes, vectors are kind of interesting chapter. You must remember some of the properties and formulae which are very easy to remember. Okay, so in next video we will continue from question number 6 and we will go on. Okay, till then, okay, I will see you later. All the best.